A very warm welcome to you all joining us for the sixth installment in the interview series conducted by the College of Chemical Sciences. These interviews are produced by the Media Circle of the College of Chemical Sciences and are here to highlight the incredible journey of prominent scientists in the field of chemistry in hopes to inspire young emerging chemists. I'm Keisha Fernandez, a fourth year student, and today we have with us Dr. Sanka Atapattu, joining us from Canada. He obtained his PhD in analytical chemistry from the Wayne State University, and currently he is a principal scientist in CanAm Bioresearch Canada. It's really nice to have you with us, sir. Thank you very much for accepting our invitation and being with us today.
Well, thank you very much for having me.
So to start off with, so as you graduated from the Institute of Chemistry Ceylon in 2001 and is one of the first students from the institute who obtained a scholarship to pursue a PhD, I would like to start off by asking you to tell us a little bit about your childhood, your days at school, and your experience in the institute.
Well, thank you for having me first. And I grew up in Kandy, and I studied at Trinity College. And when I was in school, I did well in chemistry. So it's a subject that interested me. So then after I finished my school, I joined the Institute of Chemistry. And first 2 years I studied in Kandy. Back in the day, Institute of Chemistry, they had classes in Kandy and Colombo both. But now I heard that you have only in Colombo, correct?
Yes.
Yeah. So in my case, I studied the first 2 years in Kandy, and then the third year and fourth year I studied in Colombo, and I graduated as second class upper, and then I moved to I was for a short period I was a school teacher in Kandy, and then I moved to the US for my PhD, and then I moved to McMaster University in Hamilton, Ontario. Then I moved to Winnipeg to work in industry.
That's nice. Thanks for that answer. And yeah, so you had the passion for chemistry from the beginning, and that pushed you forward. That's nice.
Yeah.
That's nice. Thank you, sir. I would like to ask Harini De Silva, who is also another fourth-year student, to ask the.
Hi.
So thank you for that introduction, Keisha. So, sir, you have done a lot of research and you have significant experience in the field of chromatography. So, what drew your attention to this field of research, and what was your inspiration to come into this field?
Well, when I went to Wayne State University in Detroit, Michigan, I met Professor Colin Poole. He's someone well known in separation science field, and he's published over 500. He has over 500 publications. He was the editor of Journal of Chromatography A for about 28 years, so he's someone well known. So I met him, and he's British, so he has a dry sense of British humor. I liked him from the beginning, and that's how I joined his research group, and that's how I was. He is the one who introduced me to chromatography.
Okay. Thank you for that answer, sir. It must be really great to have such a wonderful mentor right from the beginning to help you get into this field.
And I still work with him.
Okay, that's really wonderful to know that the relationship continue for so long.
Yeah.
Okay. So next we have Sanaya Mukandranam, another fourth-year student at ICAM, to ask the next question.
Hi.
Thank you, Harini. So in your recent work, you have contributed to a publication that explored machine learning in chromatography. How do you see AI and machine learning shaping the future for separation science?
Okay, so the publication that you mentioned is published in Journal of Chromatography Open, and in our work we used retention modeling to see the descriptors that you calculate using machine learning and group contribution techniques, how well they model in how you can model for retention modeling. And addition to that, you can also use AI tools to predict, get useful information regarding, say, for example, drug discovery. Look at octanol water partition coefficients just from the structure. So those are things I would see that potentially beneficial in the future. For example, to predict toxicity values, to see the crossing of a blood-brain barrier in drug discovery. So those things could be used in drug discovery and things like that. Also to assess emerging pollutants, for example, environmental contaminants, to see the fate of those emerging contaminants. Those kind of things, AI tools could be used to predict toxicity, fate, distribution in the environment. So the prediction, various predictions. So that's what I think about it.
Thank you for that answer, sir. It's
Mhm.
nice to see how AI is also carried forward along with science together.
Yes, and the potential, I believe, is still unknown to us. I mean, there could be so many potential applications down the road.
That's true. And so also like your work on solvation parameter model has been cited a lot. So what drew you to this model, and what changes do you foresee in this model with newer technology in computational chemistry?
Yes. So the solvation parameter model, the idea is that you can characterize partition systems in terms of intermolecular interactions. Say, for example, you can look at retention properties in gas chromatography at a molecular level to see how much hydrogen bonding, hydrogen bond acid interactions, dipole type interactions, all those interactions contribute to retention. Also, liquid chromatography. In addition to that, you can look at estimating environmental properties from structural descriptors, and estimating properties that are interest to biophysical areas, like solubility values, skin permeation. So it's a powerful model that you can use it in predicting values. So I believe that, like the previous question that you asked about AI, and even AI tools can be combined uh, to, for example, if you have in drug discovery, if you have a potential drug candidate, you can, from the structure, you can calculate molecular descriptors, and then you can estimate so many properties that of interest. So I see a lot of potential down the road there. Yeah.
That's interesting. So, like as you mentioned, that means like along with the separation that happens with the chromatography, you get to also explore other parameters and get the correlation between. Is that?
Yes, that's correct. So for example, early this year, Colin Poole and I published a paper to correlate reverse phase liquid chromatography retention factors to octanol partition coefficients. So that means you can simply measure octanol retention factors and then correlate to calculate octanol water partition coefficients. And there are others, they have done things like, for example, measuring retention factors and correlating to predict skin permeation, crossing up the blood-brain barrier. So if you have a calibrated chromatography system, you measure retention factors and you can correlate and calculate, you can estimate how much it can cross the blood-brain barrier and things like that. But you have to have a separate, take reverse chromatography, reverse phase liquid chromatography system that's with a certain conditions for that. Yeah.
Thank you so much for that answer. And yeah, that surely is gonna be very beneficial in so many applications and different areas.
Yeah, if you search surrogate chromatography systems, you can find a lot of publications in that area. Yeah.
Right. Sure, we will do that. Thank you, sir, for that answer. And yes, over to you, Harini.
I can't hear you.
So, sir, looking ahead, what are the most pressing challenges or unsolved problems in chromatography that you're eager to tackle?
I think one of the interesting challenges is to to develop analytical techniques, environmental friendly analytical techniques, and some of the sample preparation methods use a lot of toxic solvents, and sample less or less solvent consumption sample preparation techniques is one area, and to analyze a large number of emerging environmental contaminants in one method, that's another area that I think. And those are two areas I think might be useful.
Okay, so these are all techniques or principles that are leading towards like green chemistry.
Yes, that's the area that I'm interested in right now.
Yeah, we've been learning it at the institute now.
Yes.
Yeah. And so chromatography is a field of chemistry that keeps getting constantly updated. So how do you keep yourself in the loop?
Well, I review a large number of manuscripts for mainly for Elsevier journals, and also I'm an associate editor for Journal of Chromatography Open, so I get to read research papers a lot. So that's one benefit of being a reviewer and an editor. So I that's I get ideas when I read other people's research work. So that's, I think, the main reason that I'm up to date with the chromatography research work.
Okay. So the reading and the studying never stops. But
Yeah.
that's also like the interesting and the good part of being a researcher. Okay,
That's
so
right.
over to you, Sanaya.
So, as a well-experienced person in chromatography, what emerging technique or application do you believe is currently underrated and holds potential?
Well, underrated, I believe, exploring the selectivity space in reverse phase liquid chromatography. I can explain to you this way. Probably you learned about chromatography in your undergraduate classes, and in reverse phase liquid chromatography, the two main organic solvents they typically use are acetonitrile and methanol. In my work, we explored acetone as a mobile phase, and also different solvent mixtures. Typically, in analytical chemistry method development in reverse phase liquid chromatography, they try to separate using methanol or acetonitrile using a C18 stationary phase. If you don't get a good separation, you just replace the C18 column with a different stationary phase to get a better separation. But in our work, we explored using different solvent systems to explore the selectivity, and there's so much potential in using different solvent systems on the same stationary phase to explore the selectivity, and you can get separations better, explore different selectivity using different solvent systems. So we have explored tetrahydrofuran, isopropanol, methanol, solvent mixtures, and now we are into ethanol, which is a greener solvent, less toxic solvent than methanol and acetonitrile.
Thank you for that insightful answer, sir. We can still see that there's a lot of hidden areas in chromatography that is underrated as well. Thank you, sir. Over to you, Kesha.
So, like you mentioned before, that you have a reviewing role in Elsevier, and as an industrialist, what actually motivated you to take up this role? It's not a
Well, yes, it's not very many people do academic kind of research in industry. Yes, so in my case, it all started with Colin Poole, because when I was a student, he was the editor of a journal, and when I was doing my research work at McMaster University after graduating from Colin Poole's research group in Michigan, he started sending me research papers to review as an editor, because he knew my research work, and so when he came across research manuscripts aligned with my research work, so he sent me to review, and after that, other editors start sending manuscripts. So that's how I got into that. So I continued that when I was in industry. I moved to Winnipeg in 2013 to work in industry, and I still keep doing that. And also, I'm still doing research, just like a graduate student.
That's nice. And so it actually came on to you. I think when people saw your work and saw your potential, I think they just knew that they had to get you involved in this. And that's amazing how the opportunities create.
Mhm.
And also, so related to this question, the previous question I asked, like, what recurring weaknesses do you observe in early career chemist publications, and how can undergraduates and postgraduates avoid these sort of weaknesses?
Yes. So when an editor or a reviewer get a manuscript, they look at few things, and one of the things is the novelty. How novel is the research work, and the novelty should come with some significance. Say, for example, you can have a novel analytical method, but it's not better than what's already published. It's useless. So that's what, those two aspects are two key areas: novelty and the significance. And then we also look at validation work, and how the manuscript is prepared. Everything's clear, or like for example, experimental information is there. We look at the flow of the manuscript, how well it's written, and those are the main things we look at. But when you submit a manuscript, and the reviewer comments, what they are going to ask you is unpredictable, because it's it'll go to different reviewers and they see the same manuscript in different ways. So, but main components they should have is they should clearly mention what's novel about the work, and also you have to demonstrate it's better than what's already published in that area.
Yes, that makes sense. Yeah. Sometimes like there is a temptation of not having a novel thing or just putting small change compared to what is already published. But yeah,
Yes. So you have to, even if you have a novelty in your work, you have to really highlight it and
highlight it.
convince the reviewer this is a novel. It's how you present it, and clearly mention what's the novelty of the work, and also it will be useful to. I always ask when they submit a manuscript to a journal to have a comparison. You compare your method with using a table or something like that with other published methods, to like a clear demonstration.
Thanks for that answer. I believe it will be very useful for all those who are watching in as well. Yes. Over to Harini.
So, sir, many of the audience who end up seeing this interview, they have the interest in joining the industry after qualifying themselves. So, could you share the challenges and opportunities that you faced after joining the industry, and what inspired you to do so when you had to make the decision?
Yeah, so when you graduate early on and you don't have any industrial experience, it's a challenge to find a first job in industry. And what I recommend is that when you're doing undergraduate studies or a PhD, if you have the opportunity to do an intern in industry, you should take up that opportunity. Um, Usually, most universities in Canada and also in the US, when they undergraduate students, they do internships in industry. That'll give an idea to see for the student to understand whether industry is the right place for me, and at the same time to get experience. In my case, I didn't have any of that till I graduated, and then I did my postdoctoral research work at McMaster University, and after that I applied for funding from the federal government. At the time, we had natural in Natural Sciences and Engineering Research Council of Canada, and I got a fellowship for 2 years. I joined industry with my own funding for 2 years. That's how I ended up in industry. And then after that, I don't have any funding, but I got absorbed into the company.
So I think that'll be very useful for upcoming graduates or undergraduates because we tend to focus more on the research side of thing, we think. if we do a degree in chemistry, like the most the normal way to go about is to go into academics and such. So yeah, it would be nice to know that industry is also always an opportunity. Yeah.
Yes.
So to you, Keisha. Sanaya.
So, when you initially moved into Canada, what unique challenges did you face when you were an international chemist in Canada, and how did you overcome the cultural and academic barriers?
Well, in my case, I from Sri Lanka moved to the US, so it's as a student first. And when I joined Wayne State University, there was a large Sri Lankan student population at the time, so it wasn't really difficult for me, but it was difficult away from Sri Lanka, in a strange country for the first time. But I made a lot of good friends in Detroit, Michigan, in the chemistry department. And then after that, I moved to Canada. Again, I relocated to a different country, and it wasn't a big, from transition from Michigan to Hamilton, Ontario wasn't a big challenge for me, because I always went to Detroit on weekends, and it wasn't difficult for me. But yeah, it's in terms of like applying for jobs and things like that in Canada, it's or even in the US, it's important that you have a qualification in that country. Some sort of in my case, I had a PhD from Michigan, and then postdoc research experience in Canada, so it wasn't difficult. But if you're moving with a degree to Canada or to the US, unless you have some kind of an internship or some kind of educational qualification, it's difficult to find a job. So my advice, if you're moving to the US or to Canada, first to get some qualifications in that country, so that it'll be easier for you to find employment.
Thank you for that advice. Hope it'll benefit all of the listeners as well. And it was nice to hear that you did not have to face a lot of challenges too. Over to you,
Thank you.
Keshav.
And so as level 4 students, and also as those many listening in, currently we are also having a research project ongoing. So I think many of us have figured out that research doesn't always end up the way you plan it to go. So in
Yes.
such instances, how do you maintain the resilience to face the failures that come your way during research? And can you also share some of your personal experiences about it?
Oh yes, and that's research. And most of the time, you expect a research to go in a certain direction, and most of the time, it doesn't go that way. That's normal. And it's when early on in my research, it was very discouraging. And I remember when I was talking with Colin Poole, my PhD advisor, and when I tell him that, okay, this is how I want to do my experiments, and he would say, okay, it's not going to work that way. If you do it this way, it's going to work. But he always encouraged me to do do experiments the way I want to do. But always he was right, and always I was wrong back in the day. But that's research. But I can tell you a few examples. When I was doing research at McMaster University, I was trying to derivatize phenols and carboxylic acids in one method, a large number of phenols, like different molecular weights. And I was derivatizing with pentafluorobenzobromide. So high molecular weight, I had my issue was that when I was derivatizing with pentafluorobenzobromide, high molecular weight carboxylic acids and phenols had no issues. I can derivatize on the solid phase. And for low molecular weight carboxylic acids and phenols, I had to use counterion, tetrabutyl ammonium ions, to derivatize on the solid phase. Now the issue was that when I used the counterion, I could not derivatize high molecular weights. So it will work for one set of analytes. The other set of analytes didn't work in that conditions. So what we did was we first derivatized high molecular weight phenols and carboxylic acid using pentafluoride benzoyl bromide. And then we added the counter ion, like a two-step. So you can always look at the research problem if you have an issue, and you can try to navigate in a different way as much as you can. And also, this is how led me to exploring solvents in research work. First, we were looking at the selectivity of different stationary phases. And then I was trying to explore the selectivity using temperature, like increasing temperature, how the retention times vary, the selectivity differences, but it wasn't that much. So the temperature didn't really change the selectivity to a great extent, like changing solvent composition. So that led me to explore different solvent systems, for example, acetone, tetrahydrofuran, ethanol, isopropanol, and those solvent systems. And I was able to get a better explore better selectivity space in chromatography.
That's nice. Yeah, that's true. Like sometimes the most unexpected situations lead to something that's good, though it might be discouraging at that moment.
Yes, you have to keep in mind a good scientist is a good detective.
Yeah.
So,
That's
so
true.
you have to be a good detective, to understand all those results are showing. It might point to a different direction that you're not thinking of.
Yeah, make sure not to give up and keep searching. That's important. Yes, sir. Thank you so much for that advice. And over to having next question.
So, sir, this is like a continuation from Keisha's question. So, what kind of skills would you expect a budding researcher to have?
Yes, it's you have to read a lot your research. If you're given a research project, you have to understand the background. I first step is to read and understand the background of your research. And when you're doing research, you should be a good detective. That's the other part of it.
Okay. So, what kind of advice would you give to undergraduates hoping to pursue their research career?
Well, as I said earlier, I think if you're given a research project, read a lot, and always, when you're early on in research, research projects might not go the way you plan and or expect it to work, and you have to see which direction it's directing towards you, and yeah, again, be a good detective.
Yeah, so I think that's very straightforward advice, reading and being a good detective. So yeah, I hope they all follow that when they start their research careers. Okay, so that was our final question. Over to you, Keisha.
Thank you, sir, so much for your time. And of course, we all learned a lot, especially when it comes to making sure not to give up and always navigate and figure out to find the result no matter what. Like you mentioned at the end, be a good detective. And also,
Yeah.
thank you so much for sharing about your work as well. That's very interesting to know the different opportunities and like the complexity behind chromatography. I know, like, for us, we just study it in a very small scale, but like to understand the opportunities in that field of research, it was very interesting to hear it out from you.
Well, thank you very much for having me.
Thank you, sir, for your time. And that brings us to the end of.
Thank you.